Hey, everybody. This is like the second conversation that I've been lucky to have with the guest here, Boskey. And, I've been wanting to discuss what Kubernetes is like for your traditional virtualization manager, your VI admin, someone who manages vSphere and, the kind of the big estates that people have out there. So we kind of go back and forth between discussing ways that VI admins can think about Kubernetes and kind of like the types of workloads that run there and how their job is kind of different and how it's the same. And then also, we spent some time kind of on the opposite way, right? If you're more of a traditional DevOpsy Kubernetes person who hasn't really managed virtualization stuff, we kind of have a little bit of discussion of what those roles typically do and how that pans out. So this is a good companion for the first discussion that we have, but it was really fun. So enjoy. You're kind enough to come back. I think we talked last week, and we were kind of just going over. I don't know. I think I'll put it in my goofy way. I was like, what does that mean that Kubernetes is in vSphere?
Yeah.
And you were walking through it, and I think thinking about that and reading some of the other things here and there that you and other people have written, it was making me realize that there's one, like I think I was saying at the time, like I don't really know the world of vSphere very well, like what the, as we would say in the Kubernetes world, what the atomic units are, and
Hmm.
and therefore what the task people are doing. And thanks to talking with you and reading through things, I have a slightly better idea of it. And so like I thought you could do me the favor of just being teaching me some stuff here by allowing me to ask a few questions,
Yeah.
because I think in reading both sides of this, like the first thing that's like occurred to me, and we talked about this a little bit last time, but that you said this in several areas, is that basically if you're doing things in a, we'll just say virtualization instead of VI admin or vSphere or whatever, but if you're doing things in a traditional virtualization way, like like vSphere doesn't really care what's in the VMs. like or
Yeah.
and not only does it not care, like it's not part of its deal to do anything about it. And so like what, I mean, you explained that several interesting ways in a couple of places, but like what is, where does like vSphere and virtualization kind of stop its responsibility?
Got
like
it. Yeah. Yeah, we
yeah.
can get into that. So I think you know, vSphere is a way to get a unit of compute, network, and storage for me to load an application in a virtual machine. So as far as vSphere is concerned, when I say, okay, give me a virtual machine that I can put my app into, or maybe I just give it an image, that has the app in it, doesn't really matter. What vSphere's responsibility is to make sure that the app has enough memory, enough storage, and enough compute. And what it's really doing is, because it's running so many virtual machines on a single physical host, it's kind of like, the same multiple Docker containers running on a Docker host.
Right.
The vSphere scheduler on each individual host is trying to thread multi-thread CPUs, multi-thread memory access, and it kind of looks at a, its majority of its role is around resource management. Now, when it comes
Yeah.
to the virtual machine itself, there are certain things that it would like to do, and maybe it doesn't completely understand what's going on within the application sitting within a virtual machine, but that application that is going to need some CPU cycles and some memory and things like that. So we do have tools that run into a virtual machine like VM tools, etc., that will make sure that the memory doesn't, a single app is not blowing up the memory usage that was
Right.
the app is consuming. And so we have some balloon drivers that will reduce the memory and things like that. But ultimately, that is where its responsibility is more or less, is to see to it that vSphere in itself is managing so many hosts with so many virtual machines on it, and each virtual machine is demanding, like, okay, I need CPU, I need this, I need that. Its responsibility is to schedule every CPU cycle, every memory request access, storage access, etc. And at the same time, not to, not give resources to the VM, but to balance that whole situation constantly. And
Yeah.
as such, like, it doesn't look into the app and say, okay, this app has Java, so it might need more memory. Let me do that. No, it doesn't understand that capability. It just knows how much memory is being requested by that operating system. That's about it.
Right,
So the
right.
best, it talks
It
to the
sounds like
OS.
the thankless job of being a parent of many kids. You just have all these people demanding resources, and you have to apportion them out. And
Exactly. Yes.
that's, yeah,
Yes.
yeah. No, and that's, I mean, that like as I was thinking through, comparing Kubernetes and just virtualization stuff, like that's like exactly as you were explaining, that's where I was like realizing, oh, I see like what the deal with Kubernetes is, like why it's different than just like scheduling containers. I mean, or let me rephrase that another way. I see why it's a big deal that it's different than just scheduling containers,
Yeah.
right?
Yeah.
Like usually when I learn any piece of infrastructure software, it's, now that I'm thinking this, I learned this over and over again. What I learned is that I always thought the software did more than it actually does. Like, and I have this same realization with Kubernetes all the time, that like as I learn what it does, I realize there's, all these other things you have to layer on top. And I think equally virtualization is like that. And so I think, so it sounds like, now the other side of that, and tell me if my intuition is correct here to say that this is different than what goes on in the virtualization world, is that like Kubernetes very purposefully and actively does a lot of managing of the application inside the pod and inside the containers. And in
Mm.
fact, Kubernetes takes on a lot of responsibility for managing your application.
Yes. Yeah. So, like, I can think about multiple things. One is definitely it needs to schedule the pod in a given set of nodes, right? Like how vSphere does that. Like, okay, I need to give this virtual machine a host somewhere to land on. Similarly, Kubernetes does that. But the thing that Kubernetes does, and that's where I think it's a lot more amazing, is it looks at not just the resource consumption, but okay, at runtime, my app is obviously going to talk to multiple other things and it needs access to maybe a database. And I don't know what that means. Like, how do I access that database? So Kubernetes is going to give you secrets, at that point in time to say, okay, here's your database. And of course, you have to load those secrets up, but
It
it's
can't
not
just
going to
make them up.
magically, yeah, it cannot make them up yet. But that is one thing that it does very well. And then secondly, any application is up there because, there will be traffic coming to it, right?
Yeah.
Eventually. Either the traffic could be internal traffic, whether some other apps are using it, or it could be external web traffic coming to it, right? And so Kubernetes is going to not only give you a way to load balance your application pretty easily, right? Here's 10, 15 different pods that are pointing to a single external IP. Or if your app is internal, then just give it a local IP so that it knows. And then it does the routing and everything automatically. Like, you don't have to deal with any of that.
Yeah.
So,
Yeah. It's like, as always, like between, like, let's just say infrastructure as a service and platform as a service, like Kubernetes is always in this weird space between them
yeah,
that can make
yeah,
it difficult to think about it. Because as you were saying, there is there's a certain, I think introspection is the wrong word, but there's a certain like taking apart the application and the way it communicates that that Kubernetes does that you wouldn't like expect virtualization to do. Like
correct.
that, and it's like really, you know, I mean, it makes me wonder. So in Kubernetes, like this is one of the things I feel like we don't talk enough about in the Kubernetes world for developers, but there's a pretty specific, almost rigid application lifecycle and also architecture, right? So you if I'm a developer, I specify like I'm going to have these chunks of code running in these containers that are like I forget what the word is, but they always show up in these pods together. And like they're going to need like, it has to have this configuration passed into it so it can pass to the database. And
Yeah,
like there's kind of sort of like only one helpful way to architect that to like design, like you could try to design your applications against that, but it'd be a
Mm,
lot of work. And then equally so, like whenever Kubernetes, like there's those like 5 or 6 methods that you have to implement for the lifecycle methods. I think I forget, like at the pod level and the container level, and it's basically like,
yeah.
I'm going to start you up, I'm starting you up, are you started up, are you healthy?
Yes.
And then there's like, I'm
Yeah.
about to kill you. and
Yes.
and it's sort of like, I mean there is a lot of application architecture and application lifecycle that Kubernetes is sort of like, well, of course you'll be doing that. Oh, my dog's up to some nonsense back there.
That's okay.
And so with that layup, I wonder, like, does that exist in like the virtualization world?
Yeah, there's a no there is some virtual machine life cycle stages that we go through. And also there's, I mean, in fact, I would say in virtualization world, it's a lot more sophisticated. Like
Yeah.
I could do so many fancy things like CPU pinning and memory, NUMA allocation and this and that. And I could even say, okay, this particular VM can only run on this host, and if this other VM is running, please don't let it run on that host, and things like that. And then
All
even
right.
during the startup of the virtual machine, when the operating system is booting up, I could actually send scripts within that virtual machine to do some things like, okay, if this is the first time that the virtual machine OS is booting up, run this script. Or if the virtual machine is booting up ever again afterwards, run this other
So
script.
there's pretty
Right.
extensive hooks to,
Yeah, yeah,
that you can
yeah.
put in there. Right.
Yes, yes, you could do that. And you could even define these capabilities across a set of VMs, right? Like we have this concept of VApp, which is essentially more than 2 VMs that can do things together. And, but I think with Kubernetes, the idea is that we are not really, I think like the philosophy with Kubernetes is we are not really interested in that low level details around how, and we are abstracting like that to more at the services layer or more at the letting application runtimes handle that rather than giving that
Right.
very very fine-tuned capabilities within Kubernetes.
Yeah, yeah. I mean, the sense, I don't know the details well enough to know if this is like what percentage of accuracy this is, but it's
Yeah.
almost like a lot of, as you're saying, there are a sophisticated, which is to say, thorough and with lots of options set of lifecycle management in vSphere stuff, right? You can kind of, it sounds like you can do whatever you want for good or evil. And
Yeah.
whereas a lot of the times in Kubernetes, it's kind of like, just tell me what you want me to do and don't worry about how I do it, right? Like there's every now and then there's kind of worrying about things, but it's a lot more like, I don't know, it's frustrating because it's a lot more like shell gamey. Like, oh, where's the actual thing running? And you can't specify what to do. And you can tell me how many pods you want, and you can tell me kind of what load balancing, but like you can't really say how to do this, right? Like, and instead
Yeah,
it's
I
very,
think
as we would
that's
say,
where,
declarative.
yeah, that's where it's kind of like an idempotent. It expects almost the apps to be idempotent in the
Mm.
sense that they are only the only interfaces are around, okay, what do you need at runtime, I can provide that to you, but then you have to figure it out afterwards. Like you have to have it coded within the app to figure out how to do certain things. So
Yeah.
yeah.
So if I were a VI admin and I'd done all this
Hmm.
sophistication, right? And then like is there like a straightforward mapping between all this like life cycle stuff, to use my phrase, where it's like sort of like I understand how this would work in vSphere and like how I
Yeah.
would coordinate these things together. Like it sounds like a V app is a lot like a pod, right? Like you
Yeah.
have you have
Yeah.
affinity
You have
between these two
multiple.
things.
Yeah.
Yeah,
Yeah.
yeah. And I guess like what's the thing that pods are in? I always get
The containers and the pods.
yeah, yeah. There's like containers, pods, and then is namespace above a
Nodes.
pod? Yeah, no. There you go. Anyways,
Yeah, namespaces and nodes.
I need
Yeah.
my little cheat sheet here to my diagrams. But is it possible to kind of have like a mapping between these concepts
Yeah.
into Kubernetes?
I think it is all because of the way Kubernetes is designed. My thinking is you don't need it almost because
Mm,
the reason why we needed those in vSphere land was that okay, we were running heavy monoliths, right? And an app could be a lot of things bundled into a single VM. And as such, a lot of the times why you tend to do these different manipulations is that one is you want an order in how the apps come up, or
yeah.
you don't want two apps to be sitting on the same host just because you know that they're not going to like each other in terms of resource consumption and things like that.
Okay. Right.
But I think when you think about Kubernetes and containers and microservices, almost those concepts kind of vanish because now rather than taking that huge app, you're kind of dissecting that and pushing that into containers and moving it into
Yeah.
Kubernetes. And and even the components that you have broken down, you're going to have to create interfaces for those components such that two apps understand or microservices understand how to communicate with each other. That's why I was saying that a lot of these capabilities are now expected to be within the application code itself to figure things out, right? And there are interfaces for like a developer who wants to work with Kubernetes and applications to kind of create these hooks. They could leverage so many different Kubernetes concepts like config map secrets, etc., and store data like state data with or even persistent volumes and things like that. But it is almost like there are very few cases you might not really need those capabilities. And
Yeah.
there still might be cases or corner cases where you could need that. And there are some hooks within Kubernetes as well where you can do some node management or pod to node management and with VM
Sure.
to host management kind of capabilities. But I don't think those are heavily used because that's how like the nature of or the philosophy of how you're writing apps changes when you move from one place to the other. And unless you're just lifting your huge app, containerizing it, putting it in Kubernetes, then you'll kind of have to worry a lot about those things. But mostly like if you're replatforming your app, then you kind of take away a lot of those needs.
Yeah. No. Yeah. I forget what there's some name for like in the Kubernetes world for the like all modern infrastructure, especially open source stuff. What's this pattern called where there's a pipe and you can put your own pipe in between two pipes. But there's all these moments where it's like if you want to if you every time that a container loads you can put a hook in there to like do something. And I forget what they call those. They're not like sidecars, there's some official name. But yeah, like you said, you can always go and muck around
Yeah.
and change how things are working. But your example of like a lot of in the virtualization world, a lot of the sophistication is because you need to um, specify the order that VMs load, or make sure that these two VMs aren't there. Like there's a lot of, again, that comes back to like there's a lot of freedom in the application architecture that
Yes.
that you
Yes.
have, and then therefore it's almost like this is almost an Orwellian architecture. Like the more freedom you have, the more complexity there is.
Correct.
like like
Yes.
and it does I always think of this as we were watching, I forget if I made this reference last time, but we were watching like Avenger movies, and if you remember in the first part there's Hydra, and Hydra's whole deal is like people don't like choice, we need to remove choice. And it's almost like with architecture, like the more choice you remove, often the more manageable it is.
Yeah.
which hopefully
Yeah,
enterprise
and
architects aren't agents of Hydra, but
that is, we moved that, and I think that is one of the reasons why vSphere was super popular, is because we removed the need for application architecting into, like, let's say if you had, and I still remember those days where we were doing P2V migrations, right? People were running workloads in their physical host and then they
yeah,
wanted to move to virtualization. It's almost like, as long as, we had a very simple tool that would just, take the files of that operating system, layer a new operating system or OS, and then push your app code files, like your executables in it, and create an OVF or an OVA, which is like the image for virtual machines. And the only problems that we ran into were related to performance issues. That we had to kind of tweak your ESXi drivers, and that is why if you look at vSphere features, they are very, very heavily tuned to performance, high compute, where you expect workloads to be very dense and needy in terms of resources. And that is, I think, one of the reasons why migrating workloads to vSphere was so easy, because as long as your app didn't really crash because of performance, and even if it did, we could tune performance to a huge extent. Like, I still remember using this tool called ESXi Top, where it has so many knobs around performance that I don't think I see that anywhere now. But it was super easy to just convert your workloads that were physical to virtual machines, and then let the vSphere or the hypervisor take care of a lot of these, performance tuning and resource monitoring and resource allocation capabilities. So application didn't have to be architected to fit to vSphere in most
yeah.
cases. And with Kubernetes, it's kind of the opposite, right? You do have to re-architect your apps to fit into this land in some ways.
Yeah, no, exactly. And that was my next, I think we made some quippy phrase about that last time we talked, but like, I think, I mean, that was to broaden the question, or to broaden the thing I'm confusingly thinking in my head. Like, that's kind of the next question is like, so that sounds like a lot of work, right? to
It
re-architect
is.
applications. And it's almost
Yeah.
like, it makes me wonder, I've gotten curious recently about like what exactly is like the Kubernetes imperative, right? Like we on the vendor side, right? Like we're always running around saying like, you must use this new technology, and there's, people are demanding this, and you need to be doing it. And like as we were saying, like you can't just lift and shift stuff into Kubernetes, right? Like you need to re-architect things because you don't have all those freedoms, all those options, because you're not living in a Hydra world. And like, so it makes me wonder, like, do people want to go to Kubernetes because of new functionality they get, or because now they have all these applications architected in a new way, or some other thing, right? Like
Yeah.
there's like the
I think,
push to get people there is never really as obvious as I think it would be.
yes, definitely. I think in the world of ISS, it was pretty simple. Hey, you're getting maximum throughput of your huge, gigantic servers that you have sitting around,
Yeah.
that run at less than 50% utilization. So you could push 2 VMs and maybe use more
Yeah.
capacity. But with Kubernetes, it's more, there are so many micro factors that lead to people utilizing or eventually working on that. And the way I think about it, I think there are two major factors. One is definitely developers wanting more control to how their apps get deployed into this, and then
Yeah.
DevOps, or the idea of managing your apps into a platform, whatever, whether you call it DevOps or some other fancy word. But if you think about in the vSphere or the IaaS land, like, developers really have to rely on somebody from the IT world to, okay, here is my VM, I can give it to you, but then I need it to be load balanced. There is almost no concept of ingress. I mean, they could be, but you have to do so many things like, talk to a load, networking vendor. And then there's a network team that comes into play to figure out how can we route these things enough. And so software defined networking kind of solved a lot of those things, but it still isn't like one of the fundamental things with Kubernetes and is that it is taking away that need to define IPs, right?
Yeah, yeah.
And in terms of how services are managed. And so, uh, sorry, I'm digressing, but
No,
the
no, no.
first factor I think,
That's no problem.
I think, okay. The first factor I think is really how developers or the team that is responsible for building that app wants to run it, right? If they need control, Kubernetes gives them that control. They can create all kind of fanciful things within that infrastructure without really having to talk to somebody to make it happen. Like, of course, they can, load up their apps and containers and run them on their laptops. But in terms of like, I'm a developer, I'm running this app, I want to do some fancy A/B testing and see how people respond to it. I cannot really dynamically do that unless I have some
Yeah.
control of the platform itself. So I think that is the number one reasons why people, Kubernetes and a lot of the sidecar proxy kind of capabilities give them that ability. And then the other hand, where I see this is, people who have worked with vSphere and they're ops people, and they have seen applications that need a lot of handle. Like, for example, okay, I know I have a virtual machine and I know I have my resource allocated to it and all that fancy vSphere hooks. But it's not as simple as that, right? I need to run through some automation to make my final app all work together, load balance, config management, like runtime dependencies figured out, etc. So it's almost like I would be using vSphere plus maybe Chef, Puppet, Ansible, things like that to make all of that work. And so now if I go to the Kubernetes land, I don't have to work with 5 different
Right, right.
technologies. I just get everything within that same Kubernetes API. And so, it makes more sense. So I think those are the 2 key themes that I see, like why folks would want to adapt Kubernetes.
Yeah, yeah. So just to, yeah, okay. So those two things make sense. And just to I don't know, to add some words, whatever that word action is, like the first the first one, like you're making me think that like I think developers always want to write distributed applications. Like ever since I've known, they want to have like applications that are broken up into multiple parts that communicate and coordinate with each other over a network. Like it's like the great desire. They don't want to be locked in one process. I don't, and so they want to write. And object, like way back to object orientation, the idea was you would have these like little components that would like send messages to each other, and therefore they were distributed applications as well, right? And then you could reuse components the way you would reuse services, like so and that creates all sorts of like caching and coordination and dependency problems. But then like even before you get to that, as you were saying, it's sort of like you got to file a ticket to get an IP address. Right? And it really is like, even in a virtualization and in a software defined networking world, you hit a constraint of you can't sort of like willy-nilly dynamically define your own network and
Yeah,
your own things
so
like that.
like even if it's software defined networking, it's only looking at the network. With vSphere, it's only looking about how can I give this VM what it needs. With some other tool, it's only looking at that piece. And so there's still some coordination that's needed between these, components. So I
Yeah.
think that's where Kubernetes,
And then the second part is, and that was fun. Your 2 parts were on behalf of developers and then on behalf of the ops people. And then the second part is the ops people are like, every time a group of developer comes with me to a piece of software, it's just a whole other thing. We might as well start from scratch, and we've got to like build out a way to manage and monitor that, right? Like
yeah.
we always try to have standards, and for some reason they come up with some reason that they're special and they can deviate from them. Right? Like there's always some reason not to just follow the standard way of doing things. And it might be good reasons, like you're saying, for performance things or whatever, or maybe they're just pesky as developers are want to be. And so what you end up on the ops side, you end up with like all this variability and like different stuff that you need that sophistication for. And so it's almost like, hopefully, and we'll see if this plays out over time, but like hopefully the appealing thing for Kubernetes for operations people is at least two things. One is like reducing variability, reducing all of that mess, and making, as we were kind of saying earlier, there's less ways that you can do things. And equally importantly, like something until you went over, I didn't think about it, is like there's less variability in the system because we, the infrastructure people, understand these services you developers need, like ingress, right? Like we get that you need that. And we get that you need a way to like hand secrets around. And we get that you need like configuration. So like, here are these common things that every application developer is going to need. And instead of you each doing it on your own, how about we do it for you? And we don't even ask. We just say, this is how it's done.
Yes.
And so like that allows, so both of those together allow, I forgot what the second thing on my second thing was, to be, as it were. But on the developer side, you get to like finally make these crazy distributed applications that have all sorts of advantages to them. And then on the operations side, like you're simplifying things to a great degree because there's less variability and you're kind of meeting the developers where they are. And then, yeah, I mean, there's other functionality, as you were saying, like you can do, rolling upgrades and roll things back and A/B tests, which are definite.
Yeah, I think I feel like, so just to simplify this, like for the ops person, they are most likely dealing with multiple technologies to make everything work from an app's perspective. That goes beyond just a virtual machine instance running something. And from a developer's perspective, they get that control where maybe they want to leverage the infrastructure and twist it and tweak it in a very standard way, yet to their app's liking, and doing whatever they want to do with it. Like you could do some fancy feature sets, you could update, you can make your app. I think it gives you the advantage of making your application super dynamic. Is my gut feeling. Like everything with VMs and things are a lot more static and they move at a pace, right? And with Kubernetes, you could really take advantage of all these different components and just have knobs and hooks, twisting and turning wherever you want it to sell.
It's like you were saying earlier, if in kind of the DevOps way of thinking, like if developers want more control over how their application is running in production, over the running and management of their application, and control is kind of like a judgmental word, but they want to be involved in that more and use it to the benefit of their application.
Right.
Then like it's really helpful to standardize what all that functionality is, right? And not have it be sort of like, here's some custom scripts and orders of booting up VMs and like making sure the networking is working. That like all of this stuff is kind of, we have to make it up each time, or we have to come up with a standard that we do. Whereas at least with Kubernetes, there's a few default ways of doing all these common things, so that hopefully you don't have to spend. I always think like the best thing we as software vendors do is reduce the amount of meetings that developers and operations people need to go to. They'd have to go through all these meetings for months on end to specify what all this stuff is. Whereas like it's just like, here's a way to do it.
You're giving them a common interface, a standard interface to define those things, and they can use that interface to whatever suits their apps. And then we know from an ops perspective that it's getting implemented in a very certain manner, and that this is what it means. So if something goes wrong, we can even try to troubleshoot it, and it's almost like you are giving dev teams access into the infrastructure, but you're giving them very standard procedures to make that happen, so where things are going.
Right. You're not letting them just run whatever script they want.
Right. Yeah. Exactly.
Yeah. So then the last topic I wanted to ask you is like, so is around like basically like roles and responsibilities, like who is sort of doing what. And I don't know if like in like mainstream large organizations, if I don't even know what to call it, but the role of the Kubernetes administrator or operator is as like solidified as like a VI admin, right? I'm sure people are kind of figuring it out, whatever, we got all sorts of opinions, but like when you think about like, so like what if like what is the Kubernetes admin? like what are they doing?
Yeah. I think the Kubernetes admin essentially is making sure that the cluster, that the Kubernetes cluster it has enough nodes. So the apps can, in some sense, it's a vSphere admin. What it does in terms of how to make sure that vSphere has enough resources to give to VMs. I think Kubernetes admin does a very similar function in that it gives the cluster enough nodes so that the cluster can operate. It has enough persistent volumes to create disks and things like that, and monitoring the whole like system, like what's going on, how many pods do I have, are they running effectively? If not, like Kubernetes takes away a lot of those functions, like it heals things on its own. But if you are an admin and if you have apps running that need persistent volumes that need to be backed up, that is another whole thing that you'll have to cater to. And in general, the health of the Kubernetes API, such that when you're handing it off to the Kubernetes the dev teams or the DevOps teams, they can effectively run their jobs, right, on a day-to-day basis. And you give that cluster enough support so that it can stand and take all the workloads that they're pushing.
Right. I mean, to stick a metaphor into a square hole, so to speak, like you're kind of describing the role that vSphere has over all the virtualization stuff. It's basically just like, here's this base level of infrastructure, and I make sure that's cool, right? And like what you do with that is a whole other thing. Just like what the application's doing inside a VM is like a whole other thing. But my primary job as the admin is to make sure that the cluster is healthy and functioning properly. So, yeah.
And then, of course, making sure that enough people have the right kind of access, right? Like Kubernetes, if you have admin access to the Kubernetes API, you can do whatever you want. Like, you can create as many pods, as many resources, etc. So in some sense, it's like, at the namespace level, they could be giving resource quotas so that they know, like, typically in Kubernetes, like namespaces is a way to dissect the cluster into multiple teams or multiple applications. So you're making sure, depending upon what resources you have, you're kind of, giving enough quotas to these systems, to these different namespaces. You're giving people access that are at the right level so that, that not one team can overpower the entire cluster and things like that. So kind of managing that role-based access control in Kubernetes is also, I think, important. And more so because I think with vSphere, it was pretty standard. Like, you would give somebody a way to deploy a VM and that's about it. But with Kubernetes, the RBAC is pretty sophisticated. And then most likely you're not going to run a single cluster. You're going to run multiple clusters.
Right.
So you kind of have to repeat exactly what that access level is per cluster. So kind of managing that as well. So, yeah.
Yeah. Again, it's at least in my simple understanding of mine, it's analogous to like, in the virtualization world, you need to make sure that two VMs don't battle with each other. Right?
Yes,
Like
yes,
that two different applications running in Kubernetes aren't like stealing resources from each other and battling and
correct.
causing problems. So then like who manages the actual like storage and networking and compute stuff, right? Like
That would be the Kubernetes admin. I
so
think when
so
it
you think they're like in charge of that stuff?
Yeah, I think because they will. So Kubernetes like it has hooks into your infrastructure, but it can only consume what it's given, right? So
Mm.
as an admin, you have to take resources from the infrastructure and then kind of give it to the Kubernetes cluster in itself. Like, okay, you can use these volume drives. You could, here's your networking layer. Here are the IP addresses that you can use for load balancing. And, this is the total compute power is the total number of nodes you have. So do I need to, recently I was working on a cluster that I was running TAS on, and then Ben from my team was running some apps on it, some Spring apps. And he's like, my Spring apps are kind of not working. I think there's some resource constraint, and he doesn't work on the cluster. So then I went in and increased, like you could run auto scalers, like, you can increase the number of node capacity, which in turn increases your resource capacity and things like that. So yeah.
Yeah, so that's just part of the capacity management that you're doing,
Exactly.
right?
A majority of that is a lot about like giving the cluster capacity and then managing it, monitoring it, and giving people access to it. I think
And
that's major.
does that imply like I always imagine in traditional virtualization IT, there are like the networking people and the storage people and the compute
Mhm.
people. And like if you've run out of disks, like someone's got to like order the new disks
Yeah.
and like turn them
Yeah.
on, right? And similarly, like, the networking people, if they're going to be handing out like IP addresses, they have to manage that. And like, do you think in a Kubernetes world, there's still like separate functions that do that? Or somehow
No, I think
the
yeah,
admins
this is
directly
going,
manage all of that?
yeah, they'll have to, because it is so embedded that you cannot really expect three different teams doing that, because then that's the whole point of having that dynamic capability gets lost.
Yeah,
And
yeah.
so even today, even in the vSphere land, like we have vSAN, which is essentially, and with NSX or the SDN capabilities, you kind of are merging these three teams together, where that VI admin is now handling the resources, not just resources, but the network layouts and the storage layouts and things like that. So I think those worlds have already, in some sense, at least merged
Collapsed.
together,
Yeah.
collapsed. Yeah.
Yeah, yeah. So I mean, it seems like the rule of thumb, the like sort of like generalized guidance is for whatever admin group is running Kubernetes, they should have as much ownership of everything as possible, right? Like
Yeah.
of all of the raw infrastructure, because that speed that you want to achieve is just not going to be possible if you have to go to other people and kind of like
Yes.
request resources from them. So that needs to be part of what that team does, is somehow get ownership of control of that stuff. But then also they need to know how to manage it, right? So an admin like that will need to know how to manage all of those different things and have
Right.
skills for it.
Sorry, my
Oh,
son's school started, so
that's all right.
you
That's all
might
right.
see something in the background.
I'm surprised my kids haven't come in to dance around in the background in their underwear or anything like that. That's a frequent occurrence. Well, good. No, that was fun. That was helpful to understand those things. And I mean, these are a lot of the types of questions I get from the more developer sort of Kubernetes side of the world, of like how I don't know, like when it gets down to the actual management of the infrastructure, what do we do there? Right? Kind of filling
Yeah,
in how things operate.
and I think that's where it's beautiful, because Kubernetes understands, it's the single platform that understands how to talk to Google Cloud, to vSphere, to AWS, to get those resources that it needs. But then it also gives, like, you have the control of how much resources you give to the cluster itself, right? So
Mm.
as long as you take care of that, then Kubernetes handles everything about building load balancers, building storage volumes, all of that is kind of then its own job, right? So
Yeah.
and it does it very dynamically. Like imagine a pod comes up, so the pod, the container networking, the load balancing routes and everything is just taken care of by Kubernetes. So that's the beauty. I feel like it encompasses so many different things across multiple infrastructures, and you kind of have to make sure that you just give it the right uh, backing to do
Yeah,
so.
yeah. No, that you follow the way it wants you to do things. And then you can have less
Yes.
meetings.
Yes.
Well, great. Well, thanks for coming on again.
Yeah, thank you so much. This was fun.
Well, like I said, that was a pretty fun discussion. Hey, if you're interested in learning more about Kubernetes, we've got a totally great set of free resources for you, courses you can take. Boskey has a couple there, and we got all sorts of other ones. Whether you're starting as a developer or I don't know, DevOpsy kind of person or a VI admin, if you go to kube.academy, you can go check those out. And like I said, they're all free. I've done a few of them. They're pretty nice. Also, if you're more interested in developer kind of stuff, you can go to tanzu.vmware.com/developer. And finally, if you want to book some time with us to start thinking about how you're going to modernize your portfolio, put sort of like a platform like Kubernetes or the Tanzu application service, a platform as a service for developer productivity and all the good stuff that comes with that. If you go to kote.pizza, you can find a little schedule software office hours. And we can try to hook you up with someone to talk with you for an hour or a half day or a day to just kind of chart that out and start to do a workshop to figure out how to improve the way your organization does software. And with that, as always, if you want to get the archives of this show, check out other episodes, whatever, you can go to kote.io/Tanzu Talk and find it all there. We'll see everyone next time. Bye-bye.